People around Charnwood Water near Loughborough in Leicestershire have become used to the sounds of a battle submarine suddenly going into action.
I've always been fascinated in model submarines from when I was a youngster, so it's just carried on from there, and they've just got bigger. Only this one's a lot bigger than any others I've ever done.
The craft, built mainly of scrap materials, is 12 feet long and weighs 1/4 of a ton. Experts say it's ingenious. It has voices on a microchip, a hidden camera, and virtually controls itself.
Just about anything that a real submarine can do. I can tell it to go to a certain depth, and she'll hunt within 1/4 of an inch to stay within that depth. The model was built to go hopefully under and across the British Channel. People have flown across with a model helicopter, they've gone across it with a model plane, they've gone across it with an actual model boat, but nobody's ever gone under and across. So hopefully that's where I come in.
It may have taken 5 years to build, but it's the finest submarine in Leicestershire.
Yeah, there's the folding hydroplanes. There's the Hall effect switches which limit the hydroplanes when they're up and when they're down. It's also taken care of by a mixer. As we pass towards the front, this part here is another Hall effect sensor with a float which tells the hydroplanes when to deploy and when all the venting system to open and close and so on. This board here is the depth control, which automatically I can tell the boat what depth to go to, and she'll hunt within 1/4 of an inch to stay there, whatever depth. This is also part of it. I know it is actually a syringe, but it does play a very important role in the actual device itself. Down here, on that board and that board, there's 4.5 megabytes of EEPROMs, which are for the paging system and for the sound effects which come out of the speaker on board the submarine when on the surface. There's a 20-watt amplifier which is connected to part of the EEPROMs for the surface sound effects. This board here controls most of the main logic for hydroplanes, mixers, venting system, and quite a few other things as well. So it's quite complicated. That tells everything else inside the boat what it should be doing. As we pass along here, there's more EEPROMs. As we start to go towards the back, this is the compressor, which is a model boat engine, which has been converted to a compressor, which delivers 140 pounds per square inch into the main air tanks. As we go further back, there's all the valves and so on, which as they operate on quite a high pressure, 140 pounds per square inch. There's the pump down there, just down the bottom, which is for the water cooling of the compressor when it's actually running. Airflow control there. Okay. There's more boards as we work our way towards the back, which is coming up here as well. And the other side of the boat at the front, there's quite a few valves, regulators, servos, and all sorts of things. I don't know how well Derek can film this, because it's quite difficult. There's such a lot packed into here. This main space here is where there's two 6-volt 85 amp hour batteries go, so the complete space of this is filled with batteries. As we come this way here, there's the central ballast tank, which is 2 gallons. It holds of water. Inside the tank is anti-splash baffles and anti-roll baffles. At this side down here, as you can see, there's more circuit boards, but at the back of here, down there, there is the main air tanks, which store 140 pounds per square inch, which are enough to blow this tank, the trim tanks, twice over. All these boards along here, without going into what they actually do, they're for either switching the radio link for the paging system here, which is on 49 megs. This is just a vent which opens when the boat surfaces, so she takes in air, otherwise the compressor would suck the boat inside out, so it would actually implode. This just here is, if anything comes through from the vent, which is just inside the conning tower, any droplets of water come through, it's a spill chamber, a catching chamber if you like, so it only passes on air and not any water, but nothing usually comes through it. As you can see, the pipes are all dry, and that level indicator just there, there's nothing in it, so nothing comes through usually, but it's there as a safety precaution. In the bottom of the boat, there's stuff everywhere. There's down this side is the gyro, which controls the hydroplanes at the back. Just here, I don't know whether you can actually see it, but just there is a 12 volt triple diaphragm pump, which pumps water at 12 pounds per square inch into the tanks. As we come further back still, I'm doing some work on this unit here, which I've managed to break actually, so I'm having to rebuild it, because I took all the pump out and I broke the pipe underneath. It's just gone from bad to worse, but I will get it sorted out hopefully. Now, you can see the pump, which is actually down there. There's a filter. These valves are hot point 120 pound per square inch valves, which pick their 240 volts up from this inverter. Now all this inverter actually works from the radio control. It's all triac switched, solid state. Quite a few problems involved around this area trying to stop this interfering, as you can imagine, with all the different paging systems and video link and all sorts of things. It gets to be quite a problem trying to actually stop it getting into everything. As we go back here, there's more boards. Is under voltage circuitry, so if the boat is under the water and the batteries go low, it will surface and won't let you dive again, so you can't get yourself into a position where you're down and you haven't got the power to get back up. It's also linked to the radio failure circuitry as well, so if you lose contact it will blow the tanks. As we come further back this way again, those in the boat, the quarter scale servos, there's another filter here, inline filter to the pump. These are DC washing machine motors, 240 volts. As you can see, they're positive drive belts, so I don't have to worry about universal couplings and misalignment problems, and run quiet, which is one of the main things about them as well. Further back still, down here, that was an electric window motor converted into a servo to operate the rudder. So as you can see, the power of the rudder is quite powerful actually. That's through a double worm driven arrangement to the rudder. There's a quarter scale servo down there which operates the hydroplanes at the back, which is picking the information up from the gyro, which automatically levels the boat. And as we come back down this side, this board here is the logic board for the rudder motor at the back. Most of this circuitry around here, that's a regulated circuit for the video unit, actual over voltage protection as well built into that. The board down here underneath this board at the back is the which actually operates the relays to switch the boat on. So when you put it in the water, it automatically switches itself on. Coming further forward again, this board here and further up under the seal here is the FET speed controllers, which operate the main drive motors at the back, the DC washing machine motors. These turn four bladed 4-inch propellers, So as you can imagine, it's quite a powerful device. Up here is the charging socket and standby switches and so on. And then a lot of this is all just water piping, as you can see, for water in and water out. Some of the pipes are under about £12 per square inch, and others are slightly higher.
As a stationary thing.
Torpedo for the boat. It's 12 inches long, slightly over scale, but it had to be that size to get all the NICADs, the motor and all the electronics circuit board inside it to actually get it to float. There's quite a few problems involved in just trying to get something like this to actually run in a straight line, because you've not got counter-rotating propellers. You have to put a slight so many degrees of twist on the vanes, which would be the rudders, pointing the other way to the actual turn of the propeller to try and counteract the torque. It travels at about 7 miles an hour. The basic principle of how it actually comes out of the boat is you fire it out with compressed air, same as you would the full-size thing, and as it passes past a magnet, the electronics inside switches the torpedo online, and then it runs off to its target, and then as it hits, the plunger is pushed in and the actual drive motor goes off, and then the torpedo just floats on the surface so you can retrieve it. And that's basically the torpedo. I've got to get all the doors to work on the submarine yet, but I can't see that being much of a problem, to be honest.
You've got to take a whole rudder out to bend the shaft in it. Where did it?
No, I'll have to physically cut the whole lot away and rebuild it, because that's going to drop out and I'll take all the linkages down. It's been cast, the shaft moulded into it and made it. So I was going to, might have to make a whole new rig. But it's made out of chest material.
What's it made of?
Made out of chest, stuff to make chessmen out of. It was back here earlier on today, all bent, and I shoved it back. So it's still bent up, with the gaps. I could probably bond that back together with that industrial super glue. Mould all that back in, but the shaft's got to come out because it's bent.
Pete?
No.
Huh?
No, it submerges. Yeah, and travels underwater.
Sausage on that one.